Section 10.2, we're going to talk about parametric equations. All right, so here's a nice equation. And this y equals negative x squared over 72 plus x. This is the path that an object would follow if you shot it off at a 45-degree angle with an initial velocity of 48, I think we're in feet per second, 48 feet per second. And how we arrived at this, you'll learn that in Calc 3. So the object, of course, goes up, and it comes back down and eventually hits the ground. So what does x stand for in this problem? It's the distance that the object has gone horizontally. And what does y stand for? The height. So x is this distance, the distance horizontally, and y tells you how high up in the air it is. So that's kind of a useful equation, but it's kind of missing something. It's kind of missing, for example, let's pick a number that we like for x. Anybody got a number that they like for x? X equals 1. Oh, you guys aren't very exciting. If I plug in 1, I get y equals negative 1 over 72 plus 1. Well, at least I can do that arithmetic. That's 71 over 72. So what does that tell you? That tells you when the object is 1 foot horizontally from where you started, the object is 71 over 72 feet in the air. But what it doesn't tell you is, when did that happen? How much time did it take for the object to get 1 foot downfield and 71 over 72 feet up in the air? And that's where parametric equations come in. This same equation we write in parametric form. And again, where this comes from, you'll learn in Calc 3. X equals 24 square root of 2t, and y equals minus 16t squared plus 24 square root of 2t. So what does t stand for in this problem? T stands for time. So now, not only can we figure out where the object is, how far downrange and how high, we can also figure out when it happened. So for example, if our object is 1 foot downrange, when did that happen? Well, I can take x equals 1 and plug it in right there. 1 equals 24 square root of 2t, which means t is 1 over 24 square root of 2, and that would be in seconds. Now, typically you wouldn't do it that way. Typically what you would do is you would say, what's happening at t equals 4 seconds? At t equals 4 seconds, where's the object? What would you do? Simply plug t in. X would be 24 times the square root of 2 times 4. And you could grab your calculator and get a decimal approximation for that. And y would be negative 16 times 4 plus 24 square root of 2 times 2. Oh, no, times 4. And that's not a 4 there, that's a 16. I'm plugging in 4. I'm plugging in 2.
From that, could you get how far it traveled?
What do you mean, how far it traveled? Well, this would tell me at 4 seconds it's this far downrange, and it's that high up in the air. So what you're asking maybe is, could I find when is it going to hit the ground? Absolutely. How would I find when it's going to hit the ground? When y is 0. So when's it going to hit the ground? 0 equals negative 16t squared plus 24 square root of 2t, and I solved that equation. How would you solve that equation? You could use the quadratic formula. What was your answer?
Complete the square.
You could complete the square. That's one of the worst ways to do it, though. How about we just factor a t out? So 0 equals t times negative 16t plus 24 square root of 2. So once they hit the ground, it hits the ground at t equals 0, which makes sense because it started right on the ground, didn't it? And then it would also be on the ground when negative 16t plus 24 square root of 2 equals 0. So t would be 24 square root of 2 over 16. And now that I look at this answer, I'm thinking that probably plugging in t equals 4 was a very bad thing. Because I'm guessing that this number is a negative number. So that's okay. What it means is we shot our object and then it like fell off a cliff. And then it landed at the bottom of the cliff. So the ground was not level. There was a big cliff right here and it kept going down. That's what that means. So you have to cheat and make it work the way you need it to work. Because that's not very big, is it? That's probably less than 2 would be my guess. Took less than 2 seconds for it to hit the ground. Questions on that? All right, so what we're going to do in this section is I'm going to give you some parametric equations. And I'm basically going to want you to do two things with them. I might give you x equals t plus 1 and y equals t squared. First thing I want you to do is I want you to draw a graph and see what that looks like. And then the second thing I want you to do is a process called eliminating the parameter. Anybody want to guess at what eliminating the parameter means? Well, our parameter is, in this case, t. So what is it going to mean to eliminate the parameter? Get rid of t, write the equation in rectangular form the way we've written it before. All right, so to graph, what I would do to graph is I would build myself a little table here. And I'm going to plug in some of my favorite numbers. What are some of my favorite numbers to plug in for t?
Negative 1, 0, and 1.
Negative 1, 0, and 1 would be okay. So I'll plug in negative 1, 0, 1. I plug negative 1 in. What's negative 1 plus 1? 0. What's negative 1 squared? 1. I plug in 0. 0 plus 1. 1. 0 squared. 0. I plug in 1. 1 plus 1. 2. 1 squared. 1. So I have, now I just graph using the x and the y numbers. 0, 1, that's right there. 1, 0, that's right there. 2, 1. That's right there. What kind of graph am I getting? Looks like a parabola, doesn't it? It might be helpful to plug in 1 or 2 more numbers to make sure. So just for fun, let's plug in negative 2 and let's plug in positive 2. Negative 2 plus 1, negative 1, and negative 2 squared, 4, and then 2 plus 1, and then 3 squared is, 2 squared is 4. Certainly looks like a parabola because we're getting repeated y values exactly the same. So I've got negative 1, 4, that's up here. And we've got 3, 4. That's up there. So we would draw our parabola like so. And then we would also put a couple little arrows in the middle like so. What are those couple of little arrows for?
Direction.
It gives direction. So when you're dealing with parametric equations, there are two things that are important. It's not only the shape of the graph, but it's also the direction. Why do those arrows go that direction?
Because as time increases, position changes.
As time increases, position changes, and it's changing in that way. When I go from t equals -1 to t equals 0, I'm moving along in that direction. So when you draw parametric equations, not only do you draw the shape, you also show the orientation, you show the direction. All right, now how am I going to take this and eliminate the parameter and write this in a standard XY form? I'm going to take this equation and solve for t. T equals x minus 1, and then take that and plug it in there. Y equals x minus 1 squared. So are we correct? Is it a parabola? Yeah, the difference is if I had given it to you in rectangular form, you would simply draw the parabola. There wouldn't be any orientation. There wouldn't be any direction. With parametric equations, there's also a direction.
Is it a hyperbola would we have two values for x?
Yes, that could happen. If it were a hyperbola, I would have to get some points along this way, and I'd also have to get some points along that way. But I don't think those would happen at the same time. We'll find a hyperbola here in a little while. Let's try another one of those. How about, I don't know. X equals 1 plus 1 over t, and y equals t minus 1. Again, in order to graph, I would build a table. What numbers do you want to plug in for t this time? Nobody wants to pick? I'll pick some. I'm going to use 1, 2, 3, and 4. Those are some numbers I like a lot. When I plug in 1, what's 1 plus 1 over 1? 2. And I plug in 1 here, 1 minus 1. 0. Plug in 2, 1 plus a half. 3 halves. Plug in 2 here. 1. 1 plus a third. 4 thirds. 3 minus 1. 2. Plug in 4. 1 plus a quarter. 5 fourths. 3. Okay, so what do I have so far? I have 2, 0. Three halves, 1. 4 thirds, 2. 5 fourths, 3. What appears to be happening here? If I keep plugging in bigger and bigger numbers for t, look at what I have here. 3 halves, 4 thirds, 5 fourths. The next one's going to be 6 fifths, 7 sixths. They're getting closer and closer to x equals 1. But am I ever going to have exactly x equals 1? No, because I'd have to have 1 plus 0. I can't get 1 plus 0. So it does appear as though there's a vertical asymptote happening right there, doesn't there? So it looks like I got a vertical asymptote at x equals 1. Looks like something like this is happening, and orientation would be that direction. On the other hand, what happens if I plug in a couple negative numbers? I can't plug in 0 this time, can I? Plug in 0, I get 0 on bottom there. What happens when I plug in negative numbers? 1 plus negative 1? 0. Negative 1 minus 1? Negative 2. Plug in negative 2. That's going to be negative 2 plus negative a half. Oh, I'm sorry, it's going to be 1 plus negative a half. That's 1/2. And negative 2 minus 1 is negative 3. Plug in 3. 1 minus a third. 1 minus a third is 2/3. Negative 4. What would the next one be? 1/2, 2/3, 3/4, 4/5. Again, what's happening? My numbers are getting closer and closer to x equals 1, but my y values are getting negative. So what's happening over on this side? I've got 0, negative 2, 1/2, negative 3, 2/3, negative 4. Looks like I'm getting something like that. So it looks like I'm getting something that's kind of like a hyperbola. Normally a hyperbola would also have a horizontal asymptote. I don't think this one looks like I'm getting a horizontal asymptote, but maybe. Maybe I just didn't plug in enough numbers. And then orientation on this one would be which direction? What's that? Towards the asymptote? Well, let's see. This one happened when t equals 0. I'm sorry, this one happened when t equals negative 1. That one happened when t equals negative 2. Negative 3. So the direction would be that way, wouldn't it? When my t's get bigger, when I go from negative 3 to negative 2 to negative 1, I'm actually going in that direction.
So when
Are your
the other
arrows
one,
backwards on the other one?
yeah,
My arrow's backward on this one. T goes from
2
1 to 2 to 3. Yeah, my arrows are backward on that one, aren't they? Sorry about that. That one goes that direction. Okay, how would you eliminate the parameter on this one? Same way as last time, but this time I think it's easier to get the t all by itself here, isn't it? So I think I would write t equals y plus 1, and then take that and plug it in there. So x equals 1 plus 1 over y plus 1. Is that the way you would traditionally write that equation? No, what would you do? And normally you'd want to solve for y. Can you solve for y easily on that one? I think what I would do is I would write x minus 1 equals 1 over y plus 1. Think of that as being a fraction. Cross multiply. Y plus 1 times x minus 1 equals 1. Y equals, I'm sorry, y plus 1 is 1 over x minus 1. So finally, y is 1 over x minus 1 minus 1. I think I could get the y all by itself, but it's kind of a pain in the neck. Questions on that? All right, well now, calculator. Always a useful thing to have. Your calculator can handle parametric equations. The way you do that on your calculator is you hit the mode button. And you come down to here and you change from function to PAR. PAR stands for parametric. Now if you hit the Y equals button, oops, I got all sorts of interesting stuff typed in here. Notice what it gives you. It gives you a pair, x1, y1, and then x2, y2, and then x3, y3. So you can type in multiple functions. So x is 1 plus 1 over t. And y is t minus 1. Where am I getting that t from?
Variable button.
Which variable button?
X, T.
When you switch to polar mode, when you switch to parametric mode, this button, which normally gives you the x, gives you the t. So you simply use that button for t. All right, I push graph. Oh, and I do not get a good picture. What's wrong? Window. Zoom 6. Still don't get a very good picture. Why not? I'm only seeing half the graph, aren't I? Where's this half of the graph? It turns out it is a function, actually.
Is it because you can't have negative times?
Well, in this problem, t stood for time. But in general, t is time, so in general, we don't use negatives. But here's what's happening. You got to look at your window. Notice the way my window is set up. My t minimum is 0. So the smallest number my calculator is using for t is 0. So if I want to use some negative numbers for t, I need to change that to be t is negative something. What do you want to use? Negative 10. And then if I'm going to have my t min be negative 10, I'll probably make my t max be 10. And then step. Step is 0.1308996 ... I don't know how it came up with that number, but what does that mean?
Very small increments.
Right, what the calculator is going to do is it's going to plug in t equals negative 10. Then it's going to add 0.13 ... and plug that number in. Then it'll add 0.13 again and plug that number in. So this t step allows you to control how many points you want your calculator to pick. For example, just for fun, I'm going to make my t step 1. Probably a bad decision, and we'll see why in a minute. And then you've got your normal x min, x max, y min, y max, so on and so forth. If I push graph, it looks like that. Probably not very good, because my t step is probably too big, and we'll see better examples of this in a minute. But it's only plugging in negative 10, negative 9, negative 8, negative 7. You really want the calculator to plug in more values than that. So I'm going to change that t step to be 0.01, maybe. And now this is probably too many. How come? It's going very, very slowly, isn't it? What the calculator's having to do, oh, that speeds up there after a while. The calculator's having to plug in 10, then add 0.01, and then add 0.01, and then add 0.01, and keep doing that until you get all the way to positive 10. But you do see what happens by changing my t step. The calculator computes a lot more points. I do get a much more accurate graph. So that t step can be important as to how many points you pick. Now, you might notice that by picking my numbers, I missed something. It does look as though this graph has a horizontal asymptote. I didn't pick enough numbers to be able to see that pattern. Where's the horizontal asymptote happening? Looks like at -1. I simply didn't plug in enough values for t to recognize that my y values were getting close to -1 at a certain point. So just plugging in a few values sometimes isn't enough. All right, how about x equals 4 plus 2 cosine theta, and y equals -1 plus sine theta. The directions are use a graphing calculator to graph the curve, give orientation, and then eliminate the parameter. All right, so it tells us use my calculator first. Y equals 4 plus 2 cosine t. If I'm using my calculator, I have to use t. And y equals -1 plus sine t. Okay, I'm going to go look at my window. If I'm using sine and cosine, what are reasonable numbers to use for my t-min and my t-max? Usually we go 0 to 2 pi. Why 0 to 2 pi? That gives you one complete cycle of the sine wave and the cosine wave. 0 to 2 pi gives you one complete cycle. And then I think a value of 0.1 will probably be enough, so let's change our t-step to be 0.1. What do you get? Looks like an ellipse. I agree. Where's the center of that ellipse? Looks like it's at 4, -1. Right? 4, -1. What's the length of the major axis? 4. Or a better way to say it is, what's the length of A? A goes from center to the edge. Looks like the length of A is 2. And how about B? From center to top, looks like it's a height of 1. So there's the equation of an ellipse given in polar form. I'm sorry, not polar form. Polar form's like 2 sections away. Parametric form. In parametric form, the equation of the ellipse, these two numbers here give you the center, and these two numbers give you the length of the major and minor axes. How do I eliminate the parameter on those and write it in the form that it should be for the form of an ellipse? All right, well, I'm going to take this equation here. I'm going to take this first equation, and I'm going to get cosine all by itself. If I get cosine all alone, what do I have? X minus 4 all over 2. And I'm going to take this equation, and I'm going to get sine theta all by itself. Sine theta is y plus 1. And then I'm going to use my very favorite trig identity. My very favorite trig identity is cosine squared plus sine squared equals 1. So I end up with x minus 4 squared over 4 plus y plus 1 squared equals 1. And is that in the form, is that one of our equations of an ellipse? Yeah, it has x minus h squared, y minus k squared, a squared on bottom, b squared on bottom, b squared would be 1 equals 1. Questions on that? All right, let's try one more of those. How about oh, you know something I forgot? When you draw that picture on your paper, you're also going to have to draw the orientation. What was the orientation?
Clockwise.
It started here and went around that way. So your orientation would be that direction. Started here, went around that way. What if I had just gone from 0 to pi? Then what would happen?
Okay.
That would happen. You'd only get half of an ellipse. Here's another interesting thing. What if I were to take this equation and get y all by itself? I would have y plus 1 squared equals 1 minus x minus 4 squared over 4. And then what would I have to do to get y all by itself? Square root and then subtract 1. So I'd have y equals negative 1 plus or minus the square root of 1 minus x minus 4 squared over 4. If we go back to the traditional y equals mode and we type that in, we get negative 1 plus square root of 1 minus x minus 4 squared over 4. And then I got to do negative 1 minus the square root of 1 minus x minus 4 squared over 4. And I hope I have my parentheses right. One of them's wrong. Which one? Both look right.
Closing the end.
No, it's got to be the first one that's wrong.
Is it your window?
So window looks okay. Negative 1 plus square root of
Is the whole thing divided by 4 or just the x minus 4?
it's just the x minus 4 that's divided by 4, isn't it?
Yeah, I think you have.
So I have an extra parenthesis right there, I think. I think I have an extra one right there too. And let's try that.
The parenthesis after the square shouldn't be there.
You're right. So first off, you notice it's a lot harder to type it in standard form. And then what else do you notice?
There are holes.
The calculator has difficulty graphing in rectangular form when you have vertical tangent lines. And so if you look carefully, you'll notice there's a gap right there. And there's a gap right there. The calculator doesn't quite draw it correctly. However, when you're in parametric form, oops, we only had half of it now. Go back and go to 2 pi. It graphs it perfectly. So when you're in function mode, your calculator has difficulty graphing things which are not functions. This is not a function. Why not?
Vertical line test.
It fails the vertical line test. But when you're in Parametric mode, the calculator has no difficulties graphing non-functions. Questions on that?